Hey guys, so today we are working on some possible questions that could be asked of you when it comes to inflation and equations that we have. So this is one type of question. You'll get this worksheet from the substitute today, and hopefully you worked on it before you hit to this video, because I really tried to make this worksheet as user-friendly as possible. I wrote the directions, which sometimes you guys forget to read, but I wrote the directions in a way that I would say it, in a way that I would explain it. So here it says, sometimes you have to calculate nominal and real GDP of a made-up economy selling 2 to 3 goods. That's a market basket. Okay, so we're making a CPI and using a table like this. So we have 3 different years. We have items, 2 different items that were sold, hamburgers and phones. We have the amount that was sold for each of the years, for each of the products, and the prices of those years and products. So for nominal GDP, this is if a table like this is given to you. Sometimes they'll give you like real and they'll give you a CPI or something, and then you're just plugging it into an equation. But this is like without other information. You have a table like this. This is when you're going to be using these types of problems or these types of math solving things, tools, whatever. So nominal GDP will be calculated by finding out how much money was made each year. That's what nominal GDP is, like how much money was made each year, not adjusted for inflation. So for 2016 and 2017 and 2018, you're just trying to figure out how much money they made. So in 2016, they sold 10 hamburgers at $1 each and 5 phones at $10 each. So we're adding like the $10 plus the $50, which gives you, in 2016, they made $60. 2017, you're doing the same thing. Now they sold 20 hamburgers at $1.50 and 10 phones at $12 each. If you figure that out, it's $150. If I can write correctly. $150. 2018, same thing. They sold 30 hamburgers at $2 each and 30 phones at $15 each. That's a grand total of $510 that was made in 2018. So real GDP, if you are not, like right now, usually you'd be figuring out real with either the CPI equation or something like that, but that's not given. So people are like, oh my gosh, what do I plug in? That's not given. So you have to sometimes be in a table format like this. You're said like use 2016 as a base year or use 2018 as a base year. In this problem, it says real GDP can be calculated by having one of those years. Let's take 2016 in this example. I could have picked any year, but I'm going to use 2016. And that's the base year. That means I am now going to be converting these different prices into 2016 dollar values. Like if I travel back in time and told someone, well, in 2018, I made $510. They'd be like, what? It's like, well, actually, in your dollar value, it would be, that's what the converting into real is. So basically, you use base year prices. So 2016 prices is right here. 2016, $1 for hamburgers, $10 for a phone. You use base year prices, and then you figure out how much money was made each year using those prices. Okay, I think I just paused.
Just pause.
I did not pause. It didn't work.
Remember, you're picking up our son.
I'm going to have to edit this all out later. Yes, thank you.
You're welcome.
Goodbye.
Just leave it. Let it be natural. Hello, students.
No, goodbye. See you later. Okay. I'll try to figure out how to edit that out. If this is still in later, that means I either didn't figure it out or I don't care enough. Okay, so in 2016 and 17 and 18, we're using the quantities of those years, but the base year prices. So before we just like, how much money did they make? How much money did they make? How much money did they make? So now I'm using the same price for every year for both phones and hamburgers. And then we're seeing how much money was made that year if the prices stayed the same. If the prices didn't change, I'm taking out inflation. If the prices didn't change, how much money would they have made? So now for 2016, it's 1 times 10 plus 10 times 5. It's the same as real and nominal are going to be the same $60 because, if you read ahead, 2016 real and nominal should be the same value since that is the year we use as our base year. So if I use a different year as our base year, the answer of real and nominal would have been the same because that year is already converted in that dollar value because that's that year. But 2017, now I'm going to take 2016 prices because that's the base year and figure out 2017 quantities. So 1 times 20 plus 10 times 10, and that's going to be $120. Same thing with 2018. We're taking the base year prices and the 2018 quantities. So 1 times 30 plus 10 times 30, and that's going to give us $330. So these are the real values. This is like the real amount of growth they had. This had growth, but it also had inflation in it. Prices went up. Yes, they sold more, but prices were also going up. This will tell you exactly if prices were staying the same, this is how much more they sold. This is the actual growth from year to year. It's more realistic than saying, well, we made $510 the third year. Yeah, but prices also went up. So how much of that was real growth and how much of that was inflation? On number 2, it says, let's use this information from question 1 to answer another possible question type. Sometimes you have to figure out CPI. Sometimes you're not given CPI, you're solving for CPI. And that's what here it is too. So we have CPI of 2016, CPI of 2017, and CPI of 2018. Well, here's the equation where CPI is in. Real equals nominal over CPI times 100. Well, hey, you know what? I just solved for real here, and I solved for nominal here. If I plug in nominal and real into this equation, I could probably figure out CPI. So like in 2016, it's the nominal from 2016 over CPI times 100 equals real from 2016, which the equation looks something like this. This is when I did the worksheet earlier. I just wanted to make sure that I wasn't doing math on top of my head because math is, not fun. So basically 60 and 60, since it's the base year, the real and nominals can be the same. So the equation is like the real GDP in 2016 was $60, and that is equal to nominal GDP of 2016, which is still $60 over X. I turned CPI into X times 100, solve for X. Well, 60 equals 60 divided by X times 100, solve for X. Yeah, X is 100. Whenever there's a base year, the CPI will always be 100 because that means if CPI is 100, there's no inflation or deflation. So I'll actually write that down. Somewhere in my notes, I want that. If CPI equals 100, not only is that probably the base year, the camera's off. Not only is that probably the base year, that means there's no inflation and there's also no deflation. When CPI is greater than 100, that means there's inflation. And when CPI is less than 100, that means there's deflation. That means prices have fallen from year to year. But we can tell, but looking at the top, prices have gone up every year. So we're going to have CPI numbers that are higher than 100 because prices have gone up, and that's what inflation is. So for CPI of 2017, now we're taking 2017 real and nominals and solving for CPI. So remember, it's real equals nominal over CPI times 100. So for 2017, real is, where is it? It's 120. Nominal is up here, it's 150 over CPI times 100. Solve for CPI, and you're going to get 125. That's the CPI for year 2017. 2018, very, very similar. You're taking the real, I'm running out of room down here, so I'm going to write it up here. Real of 2018 is 330 equals nominal, which is 510, over CPI times 100. Solve for CPI, and you're going to get, it's going to be like 154.5, or you can say 155. That's fine too. 154.5, or you can say 155. Round up. Okay. On the back, if you can see it. Okay. It says, let's use the information from question 2. We just did question 2 when we solved for CPI to answer another possible question type. Sometimes you have to calculate the inflation rate between 2 years. It's a simple percent change formula using price indexes, which is CPIs, from different years. So we're trying to figure out percent changes between the CPIs that we just did. If these were the CPIs, what was the percent change between those years? Well, I don't know. Here's the technical, you can see it, the technical equation for inflation rate. It says price index in year 2 minus price index of year 1 over price index of year 1 times 100. But if anyone's ever solved for percent change, it's the same formula. Percent change is no times 100. That's percent change. Percent change. Which is new minus old over old times 100. That is always the case for any type of percent change. Like I weighed 150 and then I lost 5 pounds. So my new weight minus my old weight over my old weight times 100, that right there is percent body weight lost. Or my hair was this long and then I got 2 inches cut off, and so my new hair length minus my old hair length over my old hair length times 100 is going to give me my percent change of hair cut, lost. So it's like, well, which one's my new, which one's my old? These are the old years. Old. These are my new years, the most recent. So you're trying to figure out the new minus old over old of CPIs, which we just solved for in the previous question. Because I don't like flipping back and forth, here they are. My CPIs for 2016 was 100. My CPI for 2017 is 125, and then 154.5 for 2018. And now I'm going to figure out percent changes between these, depending on which ones I'm looking at. So from 2016 to 2017, here is my 2016 CPI, my 2017 CPI, and to figure out percent change, it's new, 125, minus old, 100, over old, times 100. So it's 125 minus 100 divided by 100 times 100. It should be 25%. Remember, inflation rate is in percent form. Same thing with 2017 to 2018. I'm taking, here's my old CPI of 125. Here's my new CPI of 154.5. I'm figuring out the percent change with this formula. New minus old over old times 100 is going to give me, I think it's like a weird number. It's 23.6%. And then I do a big jump. I do 2016 and the inflation rate from 2016 to 2018. So then I use the CPIs, these two CPIs. 154.5 is the new one, 100 is the old one, so it's 154.5 minus 100 over 100 times 100. You're going to get 54.5. Don't just add these two numbers together and thinking that that's going to be the same for like both years. It's not, math doesn't work that way. It's percent change, not like amount change, and that matters. Okay. This was practice of figuring out different types. I want you to ask me questions if you have questions about this in class, or leave like a comment on Google Classroom or something so I know what we're having trouble with, because this the AP test or the College Board releases a practice AP exam every year. This year, the question, the FRQ that they released with something very, very similar to this, which means they have this on their mind for this year. Does that mean something about, this coming test? I don't know. I don't make the test, but if they're signaling that, hey, this is something you should be practicing, then this is something that we should be practicing. I posted an actual FRQ that's been given in the past that was similar to this. This was given, I want to say, in 2011, because just based on 2009, 2010, I think it was given 2011. But these are some really great questions to practice on. I will be sharing the key to this. It's not a video of me explaining it, but it is a key and this is just all something you should be able to do by this next coming test. So of calculating real, nominal, even talks about how much interest and inflation and CPI and things like that. So hopefully this made sense and it wasn't too difficult. I know doing mental math can be difficult. This worksheet, hopefully you use a calculator, because there's no way you could have figured this out without one. So and same thing. Well, maybe not. I don't know. But if you have any questions, leave a comment. Otherwise, I will see you guys later. Have a good day.